Alright, so past couple of days we've been looking at confidence intervals, but now we're going to set a couple criterias to confidence intervals. We're going to go a little bit deeper and we're going to go a little bit awesomer. Anyways, so learning targets. You're going to be able to tell yourself, I can check the assumptions of a sample to ensure if a confidence interval can be determined. And two, I can calculate the ideal sample size to meet specific confidence levels. So, what are the assumptions necessary to create a confidence interval? Well, first, the sample that you are taking from needs to be independent. So, randomly selecting one sample doesn't affect randomly selecting another. And the sample size needs to be large enough that we can be sure that we get repeats. So, how do we determine independence? Well, we first need to check if it's randomized. More than likely, the problem will be saying from a random sample, 50 yada yada yada. Like the problem will literally say if it's random or not. 10% condition. So the sample size needs to be less than 10% of the population. So again, we aren't, when we take our samples from the population, we are not limiting the population so much so that when we want to take another sample from it, it's going to cause the probability of getting that certain sample size to be different. So it's like, taking 10 cards from a deck of 52 cards instead of taking one card from a deck of 52 cards. What assumption does sample size address? Well, it determines if a sample is large enough to make a sampling model. And how do we determine that? Well, similar to our sampling distribution of P, you're thinking just like, wait, a lot of these assumptions we've done earlier. Well, that's because they are, well, things that we've done. Like you're basically checking the same sort of conditions each and every time. So remember, success and failure condition. So your sample size times the proportion is going to be greater than or equal to 10, and the sample size times 1 minus the proportion is greater than or equal to 10. The slide has greater than signs because I couldn't figure out how to do greater than or equal to signs, but those are greater than or equal to signs. So, and then I thought to myself, well, the best way of showing how to find the perfect sample size is I'm just going to go through an example of how you would do it. So, Mr. Cho wants to see if Lin Camp High School thinks he's cool. He wants to estimate the true proportion of students who thinks he's cool. He thinks about 40% of the students like him. How many students, that's a typo, sorry, does he need to sample to get a margin of error of 3% with a 95% confidence? So, a lot of times questions are going to ask you, what's the sample size I need? What's the sample size I need? And a lot of companies do this, like Gallup polls do this. A lot of marketing firms do this. Um, a lot of politicians use this sort of thing. So it's really important to see, well, where's all this information coming from? So basically, we're going to use the equation for standard error. Remember, it is the critical value times the square root of P times Q over N. So in this case, our margin of error is 0.03. Our critical value for 95% confidence interval is 1.96. The proportion is 40%. 1 minus the proportion is 0.6. And our n, well, we're trying to find our n is. So basically, we're going to take what we have right now, and we're just going to solve for n. So first, you're going to divide each side by 1.96. Once you divide each side by 1.96, you are going to square both sides to get rid of that square root. And you end up with 0.000234 equals 0.4 times 0.6 all over n. And then you multiply both sides, and then you end up with 0.4 times 0.6, all divided by 0.000234. Basically, you multiply both sides by n, and then you divide both sides by 0.000234, and that's how you sort of get them to switch like that. So, what's the answer? Well, again, Mr. Cho wants to see if Lin Camp High School thinks he's cool. He wants to estimate the true proportion of students who thinks he's cool. He thinks about 40% of students like him. How many students does he need to sample to get a margin of error of 3% with a 95% confidence? So step 3, so we got n to equal 1025.6, and unfortunately, because in our world we do not have half a person, we're going to round that up. So Mr. Cho needs to survey about 1,026 students to create a margin of error of 3%. Sorry. And again, a lot of companies like these specific margin of errors because, they just like them. It's pretty standard through polls. Mitch McConnell, like, oh, how many people like Mitch McConnell? Or like, how many people support gay marriage? How many people support legalization of weed? A lot of these polls always try to shoot for a margin of error of 3%. So, what are the trade-offs of sample size? So, you get a smaller standard error, yes. So if I increase my sample size from 1,000 to 2,000, obviously you're dividing it by a bigger number. So we get a smaller standard error. But in order to reduce our standard error by half, you need to quadruple your sample size. So if we had like a sample size of 2 or 4, let's say 4, a sample size of 4, the square root of 4 is 2, but if we quadrupled it, it would be what? 4, 8, 12, 16, and we took the square root of that, that would be 4. So to increase or to decrease your standard error by half, you would need to quadruple your sample size by 4 times, because the square root of 4 is 2, and the square root of 16 is 4. So you're only dividing it by twice as big of a sample size, but you have to multiply it 4 times because you're square rooting it. And so bigger samples equals more money. So you can't just sample 1 billion people in the world, because that would be A, a lot of money, B, a lot of time, and C, nobody got time for that. So I kind of mentioned this before, but like, how are confidence levels used in the real world? So banks, when they want to see whether or not a credit card of theirs or a debit card of theirs appeals to their customers, they would send out surveys to a specific number of, like maybe like a 2,000 people or so they can get a specific margin of error to show that, okay, so the true proportion of people who would buy this credit card or use this credit card would be within 3% of 50%. And that to them sounds like a pretty good deal. Public opinion polls, like I said, they always try to use a margin of error of 3%. Same with market research firms, like let's say you have this really, really, really great idea, and you want to see if people would use it. Well, you send out surveys, but you wouldn't. But to get a specific idea of what percentage of people would actually use it, you would find that specific sample size, so you can not just waste money just throwing out 50,000 surveys. So confidence levels, real fun stuff. Alright, so now we're going to go through an example of using the assumptions. This is kind of like basically what we've been doing, but now we have to think of the assumptions that are being thrown in. So in 2006, the Gallup poll asked 510 randomly sampled adults the question, generally speaking, do you believe that the death penalty is applied fairly or unfairly in this country today? Of these, 60% answered fairly, 35% answered unfairly, and 4% said they didn't know. So we're just going to look at the proportion of people who answered fairly, so 60% or 0.6. So first we're going to look at the assumptions. Well, first it said it was a random sample, so check. 10% condition, their 510 is for sure less than 10% of all adults in the United States. The large counts, 510 times 0.6 is greater than 10, 510 times 0.4 is also greater than 10. So all of our assumptions are met, and so we can give that a big fat check. So now we're going to create our confidence interval. So again, standard error equals 1.96, which is again our critical value for a standard for a confidence interval of 95%. Plug in our numbers, and we get a standard error of 0.0425. So now we're going to interpret it. So we are 95% confident that the true proportion of Americans who believe in the death penalty being applied fairly is between 0.5575 and 0.6425. And that is all, folks. Great. I'll see you later.